Welcome to homework.
The an terms that we're looking at is n squared times e to the minus n. So another way of writing this is n squared over e to the n. So we should know already that this is going to go to 0 because we have polynomial growth in the numerator and we have exponential growth in the denominator. You can also prove it using L'Hopital's rule. All right, this will be an easy thing to work with for L'Hopital's rule. So we're allowed to use L'Hopital's rule when we have something that would give us infinity over infinity or 0 over 0 if we were to just plug in the value of n here. So if we were just to plug in n equals infinity, we would get infinity over infinity here, right? That's something that we're not actually allowed to do because infinity over infinity is indeterminate form. But if we are in that type of situation, we're allowed to use L'Hopital's rule, which means that we take the derivative of the top part and we divide by the derivative of the denominator. So we'd get 2n, that's the derivative of n squared, divided by e to the n, that's the derivative of e to the n with respect to n. And then we're in the same setup, so we do L'Hopital's rule again, and we get limit as n goes to infinity of 2. Derivative of 2n with respect to n is just 2, and in the denominator we still have e to the n. So now we'd have 2 over infinity, which is 0, so we do converge. We converge to 0, right? And we should know this immediately from looking at it because, again, exponential growth is much faster than polynomial growth. So in the end, this e to the n is going to completely dominate over the n squared, and the whole an term is going to end up going to 0.